1,000 years old near the bottom. So most of that bottom you saw there is 500,000 years going into the Ice Age right in here. They think this is an interglacial, by the way. This is the Ice Age portion right in here, and this is the post-Ice Age, just 10,000 years. But most of their time, most of this time right here, this is a couple hundred meters, is right in here, because their annual layers are so compressed by what they believe, by their assumptions. This is the GISP 2 core from the top of the Greenland ice sheet. And this is sort of similar, but you have a lot thicker Ice Age ice sheet right in here, about 1,500 meters thick. And by the way, see all those wiggles in there? That's giving them the idea that we have catastrophic climate changes. Clear up into where it's starting to warm up, called the Younger Dryas period. And that has got a whole new paradigm in climatology, and where they're afraid of we can do something with the climate and we're going to cause a 10 to 20 degree centigrade cooling in a matter of a decade. That's what they're believing nowadays because of the Greenland ice sheet. But these, I believe, are Ice Age fluctuations right in here of one quick ice age. And this is the post-flood ice right in there. So these are some of the cores of the Greenland ice sheet. Now, how do they miss these annual layers? Well, here's how I think some of the reasons. I think with a lot thicker annual precipitation, you keep the wiggles from storms. They're picking up storm layers, which a lot of times duplicate the annual layers, but they think by diffusion they're smoothed out. So if you have 20 centimeters a year at the top, like you do now, and you have all these wiggles due to storms, the winter and the summer being a little warmer, after it's compressed and diffused, you get this feature right there, where all those wiggles are, and that's one annual layer. But if you had 2 meters a year, which is about that much of precipient ice, those wiggles don't get diffused out when you compress the ice, and they remain. And so they would come in here, even though this is 1 year of precipitation, they'd count 1, 2, 3, 4, 5, 6, 7, 8, 9 peaks for 9 years. So that's one of the reasons why I think they're picking up a lot more annual layers when we say the annual layer thickness is a lot greater than that. Another reason is because of the resolution. When they get down in the ice sheet, they're picking up dust fluctuations of dust. And so they used a resolution for this way of picking up the dust of 8 millimeters. And at 2,800 feet deep, they got an age of 85,000 years. And they said, that's way too young. Well, why? Well, it's because they were assuming other variables, other climate variables to date it. And they said, you need more years. So what they do, they increased the resolution to 1 millimeter and picked up more annual layers and got 25,000 more years in a 500 meter thick layer. They got 25,000 more layers when they redated it. And here's how I think they did it. With a higher resolution, you pick up more wiggles in here. And so instead of having 10 annual layers in here with 8 millimeters resolution, you have all these. So I think those are some of the reasons why they can't see the bigger annual layers, is because of their analysis scheme. For the Antarctic cores, it's totally different. This is the Vostok core, and they have these big wiggles, one there, one there, one there, one there, and one there. There's essentially 4 of them. And they date these big wiggles by just assuming the Milankovitch or astronomical theory of the Ice Age, where every Ice Age repeats every 100,000 years. So they say this is recent right here, this is 100,000 years old, this is 200,000, this is 300, this is 400,000. They're only dating by wiggle matching from other assumptions. And that only went to 4 cycles. Now that's Vostok. Dome C, they go to 9 cycles, and they claim there's 900 years. So they cannot date the Antarctic ice cores by annual layers, because the amount of snowfall on the top of the Antarctic ice sheet is only about that much. It's extremely dry there. It's drier almost than the Sahara Desert. So they cannot date by radiometric methods. Antarctic cores are dated by matching wiggles to deep sea cores that are matched to the 100,000 year cycle in the astronomical theory of the Ice Age. Essentially, it's only dated by assumptions. It's just simply based on, they assume the the Milankovitch or astronomical theory, and that's how they date deep sea cores, and that is the way they date from the deep sea cores. They use those wiggles and date the Antarctic ice sheet. And by the way, this also goes into the Greenland ice sheet in a different way. So, that time is really based on their old age assumption. To make it simple, they assume old age, they see old age. To make it simple, that's a simplification. But a lot more details you can find out in a book published just a few months ago by ICR Technical Monograph, The Frozen Record, examining the ice core history of the Greenland and Antarctic ice sheets. And this is my last topic, the Lake Missoula flood. To kind of bring you up to speed a little bit, here is Lake Missoula right in here, filled up the valleys of western Montana from an ice lobe right in here. And then when it broke, it came through eastern Washington, forming the channeled scablands, which are deep coulees cut in the lava, the basalt lavas that are vertical walled and flat bottom, and forming Grand Coulee, Palouse Canyon, where Palouse Falls is, rapidly. Now, the interesting thing about this, that the evidence is overwhelmingly that you had this flood, but they rejected it for 40 years. Why? Because it was too biblical, too catastrophic. The establishment, as represented by the United States Geological Survey, closed ranks in opposition. Instead of testing Bretz's flood on its own merits, they rejected it on general principles. Too catastrophic. Here's where the ice sheet was in western Montana. It blocked the Clark Fork River. The lake was 2,000 feet deep right here. And over Missoula, Montana, it was 1,000 feet deep. There's shorelines all through these areas that you can see along the mountains. In fact, here's one right here above the city of Missoula. You can see the shorelines right in here, up to about 1,000 feet above the city of Missoula. Here's the University of Montana. On the other side of the freeway, that way, you see Mount Jumbo. You see more distinct shorelines right in there. And by the way, there's a glacial Lake Columbia blocked by the Okanagan lobe. So you had two lakes right in here, but this was the largest lake by far was Lake Missoula. And here's the channel scablands right in here where it eroded through the windblown silt on the top and into the basalt. And came through down the Columbia River, came up the Willamette Valley, and down into the Pacific. And here's some of the evidence for this flood. This is the Little Bitterroot Valley northwest of Missoula, and this is a low ridge right in here. But it was about 800 feet below the surface of Glacial Lake Missoula. And then when Glacial Lake Missoula broke, the ice broke all in one day. It rushed 60 miles an hour through this valley and formed these ripple marks going down Camas Prairie.